Hi everyone, welcome to MasterCAM, the complete course. I hope you are fine. So we have already started the module number 4, which is all about the chaining and toolpath parameters. And here we have some topics here, which are chaining basics and chaining options and basic toolpath workflow. I'm going to tell you what is the toolpath workflow actually is. And toolpath type, tools and holders, channel cutting parameters, and linking parameters. In the previous video, I just give you an overview of this module, which is module number 4. It's just basically we are doing the 3D toolpaths in this module. In the previous videos, we did the 2D toolpath using the wireframe, and in this module, we'll just apply 3D machining strategies or machining techniques on our 3D model. So first thing we should know about what is the toolpath workflow. So let me define this by giving you this picture. That first thing we know, we import our design. As you know that the MasterCAM is a full functionality of CAD and CAM. So you can also create model inside the MasterCAM, or either you can import it from another software. Okay. So the first thing you know is we have to create a model or import CAD model in this software. Okay. Then what we do, we have to define our machine. So whether our model is going to be we are going to work on a lathe machine, or we have to work on a milling machine, machining center, or wire cut or CNC router. So we have to define the machine regarding the import model model we have created. Then after define the machine, we have to set our toolpath techniques. So for all machines, after defining the machine, whether it's a lathe machine, so toolpath techniques will be different than the milling machine toolpaths. Okay, so for example, I have a milling machine and model is related to the milling machine. Then the toolpath techniques will be definitely regarded with the milling machine. Okay, then after applying all the toolpath techniques, applying tools and cutting parameters, all these toolpath techniques, then what I have to do, I have to check whether my toolpath is according to my requirements or not, whether the cutting toolpath is performed well or not, or the cutting tool is not going to be collide with the fixture or table or any other thing. So we have to check it. And what through we check, we use this simulator or simulation or verification of the toolpath. Each toolpath is being verified thoroughly, or after thoroughly verified, we generate the G codes according to our machine. So we have to set our machine that we have a generic CNC milling machine we are using. Then we create and generate the NC code for that machine. We copy that CNC code, or we call NC code, and then we load this NC code into CNC machine for the real program to be done. Okay, so this is the basic of a toolpath workflow we do in almost all type of CAM software or CAD CAM softwares. For example, if you are working on a MasterCAM, you have to apply the same technique while creating the NC program for a machine, or either you are using the other software like SolidWorks CAM or Fusion 360 CAM, NC CAM, or another software, BobCAM software or PowerMill software. So the technique will be same, totally same. There is no such difference between all these things. Okay, so let's move towards another thing. Let's discuss the toolpath techniques in this module. So today we are going to create a 3D model, and then we will apply toolpath techniques on it. Okay, So first thing first, what we are going to create, we should create from the wireframe. Okay. So I'm going to create simple 2D geometry using the rectangle and anchor into center and just create a simple rectangle. Width is 213. Let me make it 300 millimeters and the height is 100 millimeters. Okay. Now what I'm going to do is I'm going to create a solid from this side. Yes, select the chain. Okay. So it shows nothing here because I have selected the wireframe only in view. You can select a solid shaded, so you'll get the real result. Okay. So don't worry, you have to select the appropriate graphic view here. So here I've just showed the shaded view or the display. So it shows that it will make 50 millimeter in upward direction. Let me make it to downward direction in 50 millimeter. Okay. So what I'm going to do is I'm going to create some simple geometries here. For example, go to wireframe and I'm going to create a round here. Okay. So the diameter would be 15 millimeter. Okay. And how about I'm going to create another thing, which is an ellipse. Okay. Okay. And not like that. I want that. Okay. This size is 30 and the B size is 20. Okay. So just give some relations that I just want this circle to be at the center. So just go to drafting, go to transform and translate this. So I just want to translate this ellipse from certain point. So I select that the quadrant on the grid point. This point to let me go to the top view and set intersection point. This one. Sorry, and let's kind of get to a little. Yes. Here. Okay. No. Okay. And now what I'm going to do is I'm going to delete certain things here. Go to trim and select. There's some. Go to this. Or just look that thing. And so let me go to breakpoints, this point and this point. I just want to break it with K. And what I'm going to do is I'm going to take a mirror on the other side. So just select this and go to transform and make it mirror. Okay. So it will make mirror in the Y direction, not in the X direction, but in the Y direction, like that. Okay. So is in X direction the same, but in Y direction it will be made on the plane and to the right side. Okay. Now go to again to wireframe and make some editing here. Break 2 points. Yes. From here. So delete all those. Okay, now what I'm going to do is I'm going to join all these two. Okay. Okay. Joining it. App search.
software, just join this entity. And let me go to entity. Okay. So we just created a geometry here, and what I'm going to do is I'm gonna extrude cut here. So go to solid, extrude, and what I'm going to do is I'm going to extrude this geometry inside in the form of cut. So it cut through all. Let me decide that I have to down this at 20 millimeter. Okay. So this is what we did, and we create a ellipse here, and the circle at the center point. Now let's make some extrude boss base here. Okay. So just go to wireframe and create some polygons here. Okay. So go to top and just make this polygon. Here's some. Remove this corner. Okay. So I just give random, and what I'm going to do is just select this and this, and going to mirror this geometries on the other side. So what you see over here, that in the X direction and in the Y direction, you could create the geometry. So if you want to create in the Y direction, just click to Y direction. Okay. Okay. And what I need is, I just want to select this, make it on the other side, in the Y direction, in the X direction. So let me reselect this, and what I'm going to do is I just move this. Okay. And just want to make polygon scale. Okay. And what I'm going to do is I'm going to extrude this boss base on this surface. Go to solid, extrude, and select the chains. This, all this. Okay. So we have created the cut coordinate. We want to create a body here on the upward direction. Okay. So just select this upward direction. So just make it 10 millimeter above the surface. Okay. So just create simple bodies here, and let me just some chamfers on all these, or you can just select the faces. Okay. And select these faces. So here I will just select the face. Okay. And it just gave the chamfer only 2 millimeter. Okay. And how about this area? So let me select the corner edge. Okay. So you just give the chamfer on this. Let me make it a little bit more, like 5 millimeter. So that's it. And some rounds on this. So let me select fillets here, and okay, this point, fillet. Okay. So how about the 5 millimeter, 10 millimeter? So let me make it 10 millimeter fillet around this go. So this is how we create the geometry, and what we're going to do is we are going to apply the 3D machining strategies here. So first thing, we have to select, we just create the model. Either it should be 2D model or 3D model. Then what we are going to do, we have to select the appropriate machine for the model. So my model is all about the milling machine. So I'm going to select the milling machine, default. And what we are going to apply here, we are going to apply the pocket machining here. Okay. And for that, first thing, you have to create a roughing area here to create all these extrude boss case.
So for that purpose, you can either select the 3D machining strategies. Here we have roughing strategies like optimize rough, pocket, project, parallel, plunge, multi-surface, and area roughing. Okay. So if you are going to create a pocket here, you just need to select this and to create pocket. Okay. You can perform these strategies to create all these things here. Okay. So let me go to first roughing strategy, optimize rough. And here the dynamic optimize rough options are here, parameters are here. It shows that you have to select the machining geometry and the avoidance geometry. There are two types of geometries here. The machining geometry is what you are going to machine. So what I'm going to machine is I want these things and all these cavities and the extrude pulses. So actually I want the whole body to be machined. Okay. So what I'm going to do is I'm going to select my whole body. You can just go and drag and drop the select, or you can select it by Control plus A to select the ball. Okay. So it just selected all the entities and the wall stock and the floor stock is 1.0. Okay. You can just give the 0.0 wall stock and the floor stock 0.0. And what about the avoidance? Avoidance area is the area which you don't want to be machined. Okay. You have to select that area which you don't want to machine. So this is what we call the avoidance geometry. Now let's go to the other option, which is the tool path control. You have to give a boundary to define that this is the area under which my cutting tool will machined all these things. Okay, so it's a boundary around your geometry. So you have to select it. Containment boundary is the area which contains the machining area. Okay, so just I'm going to select my wireframe. Just so it select the 2D wireframe geometry. Either you have a 2D geometry or 3D geometry, you can select it. For example, let me give you that I'm going to select the 3D, and in 3D we have these corners like this. Okay, so in 3D it select the 3D edges of the part, solid part, and but in the 2D it will select it. Let me go and clear this. Just go to this, and it will select the 2D wireframe geometry. Okay, so you have to select the appropriate method which you are going to use. Okay, so strategy is the cutter will be cut from outside to inside, or you want to cut from inside to out. So in this case, I just want my cutter to work from outside to inside. Okay, and what area you want to be compensate? Either you want your cutter to be work inside the boundary, or outside the boundary, or in the center. So as you see that the cutter is at the center of the boundary line. It means that half of my cutter will work inside and half of my cutters will work outside. How about the inside? All cutter will work inside of the boundary, and outside means the cutter will work outside of the boundary. So what we want is we want our cutter to be work inside of our boundary. Okay, select. So all these things we have done it. Now let's move towards the tool. So you have to select an appropriate tool. You have to know that how much distance that we have here to create all these area to be machined. If the distance is not enough, the cutter will be not go and pass through this less width area and will not machine that area. So therefore you have to select an appropriate cutter. So let me define that I'm going to use an end mill cutter for the rough operation, because for roughing operation most of the time we use the end mill cutter.
the thing.
And select the 5mm end. Okay. So I've just given you an idea of how we can select a cutter. You have to select the cutter according to your design specification. Okay. So if cutter diameter is 5mm, cutter length is like, we'll define that my cutter length is 30mm. Okay. It's just give you an idea. And the 80mm. Finish. About the speed is 21. Let me give that. I'm giving you 10,000 RPM, spindle RPM, and 3,000 millimeter per minute feet. And the plunge rate is 300 millimeter. Give the tool number 1 for this operation. And for all these things, we have just done it. Now let's move towards the cutting parameter, which is the most important thing you have to be you should know about the cutting parameters which you are applied. So the first thing is this step over. The distance between each toolpath is called this step over. So every time it will take in a step of 1.25 mm. It means that we are using the cutter 5mm. So it's going to be 25% of the cutter will be take a step. So it makes that 1.25mm. Okay. So it's okay. We're going to make 1.25mm cut. The next thing is the most important thing. You have to tell the machine or tell the software that how much cutter will take cut or step down every time. So it will take 5mm cut every time to take. So this is what we call the 100% cut. So this is nearly impossible because the cutter we are using is 5mm cutter. Okay. And if it takes 5mm depth at certain time, it will get break. So what you need to do is you have to set the depth of cut according to the cutters you are using. So there are different types of cutters in the market, like that. If you are using the high-speed steel cutter, the cutting parameters will be different. And if we are using the tungsten carbide cutter, the cutter definitions and the parameters will be different. And if you are using the PVC and CVD coated cutter, the cutting parameters will be totally different. Okay. So therefore, you should know all the cutter parameters and how much the cutter will take cut every time. So let me define that. I'm going to make cut of 2mm each time. Okay. And there is an option here in the step down, that step up. Step up means that the distance between step down is 2mm, but every 2mm, how much step it will take? 0.5mm. Okay. And this is what we're going to tell that it will take minimum amount of cuts every time between 2 cuts. Okay. So it gives cutter live in place moment and gives the cutter finishing to the workpiece and gives no precise chips. Okay. So these are the cutting parameters we have done. Then the next thing is steep and shallow, and defines the depth of our machining area. For example, we have the depth here is I think minus 10mm or 20mm, and we have this step here is 10mm. So it's in Z direction is 10. It will automatically define the minimum and maximum depth of our design area. Now next thing is linking parameters. Linking parameter is that we should have to define that the cutter or each tool path is connected with each other. In such cases that the clearance plane is 50mm. Mean to say that we have the Z axis here at the top of the workpiece is 0mm. Okay. So this is what we have, the Z 0mm. what it will do, it will take all the machining operations done, and after done all operations, it will go back to 50 millimeter from this point. So this point is called the clearance point. So it will be always 50 millimeter above the 0 point. So it's okay. We want it. What we want in absolute or in incremental, we'll definitely select the absolute. So the next thing is the type. Either the cutter will take full retract, mean to say it will definitely take each step, first goes to 15 millimeter high above and then go to another. So it will take full vertical retract, or it will take minimum retract, vertical retract according to our geometry. For example, what you see here is we have 0 point here and we have maximum point here, which is 10 millimeter. So it will automatically set the tool path clearance according to our geometry. So this, what happens, this will lessen your machining time, increase the machining tool path. Okay. So what we do is we have to select the minimum vertical retracts. Okay. And how about the part clearance? And the part clearance is 4 millimeter, mean to say that it will be always high above the part, which is 4 millimeter. You select 2 millimeter, it will always high above to 2 millimeter from the, okay. So the lead in will be the same as lead out. It's always at 0 distance at an angle of 90, definitely takes at 90 degree cut. So all these things that to keep tool down within 500%, and the micro links, all these things we don't need to change. With all these are by default settings. Okay. So go to coolants. We have the plane. I've already selected the top plane, and next thing is coolant. Just select the coolant on, click OK, and just wait for the machining strategies to be performed. While the machining strategies want to be calculated. So I just click here. It shows that tool path regeneration is processed. Operation editing not allowed until the regeneration is completed. So just wait for the operation strategies to be performed. So you see here that the machining strategies is being performed, and what you see over here, the cutter is start the machine tool pass every time. Okay, so it takes the 2 millimeter step at machine D or okay. So this is how the machining is being performed. So let's go and go to another view. Because we have created the tool path strategy, now what we need is we have to verify whether our machine tool path is okay or not. Okay, so as you know that we have selected the machine strategy from outside to inside, so therefore the cutter will be moved outside to inside. So if you go to parameters and setting strategy, go to tool path control, take strategy from inside. Let's see what happens. Yes. Just wait for the machining strategies to be calculated. You can either create some new strategies, as you know that our machining strategy is being generation process. So you can either go and apply some other strategies. Like, for example, I'm going to tell you that we are going to apply the control strategy. So the control strategies applies on the outer surfaces, just like we did on the 2D toolpaths. Okay. So what I'm going to do is I'm just going to select the surfaces, outside surfaces, and these are all my outside surfaces, which I just want to machine them. So just select all these and OK. So we have 8 driving strategies, and let me select the containment to check. I just don't need any containment because I just want to remove material from the outside. Just click OK. So let me go and select an appropriate tool. Go to filters, and then select ending. Just want to select the 10 millimeter ending. And the height is of the whole machine. Cutting length is 50 millimeters, roll that to 150. That I set to OK, finish. And just to make it by default cutting speed, just wanna tell you that how it material. Okay, the surface parameter is absolute. So just need to know that the retract point is in incremental. Let me make it absolute. How about the feed plane? The cutter will be feed into the workpiece at the 5 millimeters. Let's go and select the absolute for 5, or let me give the 10 millimeter. Okay. I want the compensation is inside or outside. Just making compensation inside. Okay. And how about the finishing control parameters? Let's make it the cutting 1 millimeter cut. And it will take frame cut. It will move like an helix and cut. And the direction to open contour, there is no such open contours available. So therefore, we don't need to select. So I just want to make the cut optimize order. So just select optimize. And okay, that's okay. Open this script. Okay. So what you see over here, just created a 2D strategy or machining 2D strategy over. So cutting toolpath created, and it creates a contour around this solid body. So this is how we can create 3D toolpaths for the 3D model. So we just need to give the containment, because as you see that this is all done outside and same in the inside. So just don't need to work inside. So for what we're going to do is has applied to containment. Select twice. Okay. Go to parameters, toolpath parameters, and select the containment. Here, we just want to tell you that we need to select the containment. So for 3D, let me show you. We want 3D. So go to 3Ds and select the surface. Okay. Okay. And inside, no, we do want it outside. Okay. So we're just creating and optimize the cut order. Stipulating. So it's taking the optimized cut order. So all these things depends upon your computer processor, how much processing you have. So it will, the higher your processor values or RAM values, it will take less time to calculate. Okay. So all this processing depends upon the your computer hardware performance. So it's just recalculating. It will take some time. Forward. Seven. Forward. Turns forward. And then. Four. So for that, can't do anything because it's creating. So just given an error here. So let's go and select the sort chain here. Go to parameters, and if we selected the outside, set the inside. Let's see. So it just what's happening here? It doesn't make anything. We're but to change the side. Let's make the side in the outward direction. Okay, and just select the outward direction. Okay. That's super. What the parameters? Because surface parameter make it outside. Keep checking in optimize cutting order. Let's see what happened. So sometimes it gives you an error. You don't need to worry. Just go back to your settings and apply different settings every time to get your desired results. So what you see over here, it just created a contour around the body. Okay. So just want to show you that how it works like. Okay. This is done. So let me go and I'm going to delete this strategy because it will take some time for machining. Let me show you the other view, verify this toolbar. So just select this verify and go to machine and verify this toolbar. So it's calculating your G codes or machining toolbar strategy and verify it. So what I'm going to do is before going to apply, create a G code, I would just want to see whether my workpiece is going to be done according to what I want, or all operations are going to be performed. When is there any accidents here? It will show accidents on workpiece. So we'll check all the machining strategy here, and after verification, we'll just create G codes and load that G code into our machine. So let's go and start the verification process. So just go and click on the play button to verify. Definitely it will take a lot of your GUI or your processor and your graphic card. It takes some time. Okay. So this is how it will take cuts in a dynamic way, and it will take a step over at 1.25 millimeter. Okay. So here you see that, and just create the polygons here, and just move to the other way in a dynamic way. Okay. The cutter is using 1.25 millimeter step over. And take a depth of 2 millimeters. Okay, so there is some what we got is okay. Fail support. Subject done.
You can also increase your
speed. Okay. So this is how the machining is done here. This is what we call the dynamic machining. So here we have the 2D geometry at that plane. So all operations being performed on this are the roughing operations, not the finishing operations. So just to see that how the surface is created here. So this is very rough surface is created. So we have to apply the finishing strategy to the part after doing the roughing operation. So here you will see that the more information about the invoice ID and the time and the machine. The movement is linear feed and the operation is 3D. It will give you all these data here. And the toolpath information all about that. This toolpath time will take around 1 hour and 47 minutes to complete. And the rapid length is all about this. All this thing will give you all data. Okay. So this is how the machining is being performed here. We have verified our toolpath that toolpath is okay, our design is okay, what all the parameters are okay according to our file. But you see here that it creates little small steps here. This cause use the dynamic rough operation here to perform this operation. In the next, we're going to perform the finishing operation. Okay. So in the finishing operation, it will move all these burrs or steps. Okay. So in the upcoming video, we'll define how to apply the finishing toolpath strategy. Actually, we're gonna cover all the 3D toolpaths. Okay, we just apply the optimized rough. Then we're going to apply the pocket milling operation, project milling operation, parallel, plunge, multi-surface and area, and some finishing strategies to work this. So I hope you understand how we created the 2D 3D model and then apply the 3D optimized roofing strategy to our workpiece. And then what we did is we just verify our toolpath. So the next thing is, after verification of the toolpath, we just need to create the G codes, which these G codes or M codes will run on our machine. So you can just go to machine and click on generate. So this icon G1 to represent the G code. So we have selected our strategy, which is 3D high speed milling, and just click on G generate button. It will create the NC extension code and it will create G code for your machine. So just I have click on the generate and it will show that where it should be saved. So I just want to save on desktop. I'm going to give you 3D to optimize 3D toolpath. Okay, click save, and what it will open the G code editor. So it's going to be create your G codes for your machine. It will take some time according to the according to your machining strategy. It will take some time. So the G code depends upon the, as you see that it will take too much time. This is because we have set our step over 1.25 millimeter and the depth of cut is 0.5 millimeter. So therefore it takes a lot of time to cover all these, to generate toolpath for all these depths and step overs. So make sure that you have to select the appropriate step over and toolpath depth, which will also decrease the size of G code and also lessen the file size. Now you see that it will take a lot of memory while generating the G code. So make sure that you have to select the appropriate step over and depth of cut while generating your G code. Okay, so just if you go and change your parameters, just give 5 mm depth cut and a step over of 2.5 millimeter, it will create less than G codes. It will create faster than this start. Okay. So let's wait. Let's wait for the results to become. So here we have the size. So here we have the G code for our toolpath strategy. So these are a lot of toolpath strategy G codes. As you see that the cursor is not moving so much. So all these are the program which is going to be fed into your CNC milling machine, and it will create a real product for you. So this is your program, and what you have to do is you have to save this program into your USB, or you have to direct send this toolpath track to your CNC machine. So I hope you understand, and stay tuned for more operation. In the upcoming video, we are going to apply more toolpath strategies. So thank you very much and stay tuned.